একটা জিনিস মানে এক বছর হয়ে গেছে, but still there are so many new things that are coming up, right? So that's the
Yeah.
main issue that we need to touch up on over here. So let me just check if we are live right now. Supposed to be like, yes,
Sure.
we are. Okay, so uh assalamu alaikum everyone. So I am Humar Salman and we are here again with another session of COVID. Sorry, one second. Let me just turn this on. Okay, so we are here for another session with CMI Social Awareness and Community Reach Projects. And today we have with us Mr. Rakib Hafiz. So would you please go ahead and introduce yourself?
Hi, Assalamu alaikum সবাইকে. My name is Rakibul Hafiz. I'm a third year PhD student. I'm doing a joint PhD program with the State University of New Jersey, which is Rutgers, and then a technical side from New Jersey Institute of Technology. My focus and my concentration in PhD is basically neuroscience, and my specialty is in functional magnetic resonance imaging, fMRI. And we usually work with neurodegenerative populations, and we try to find out what are the issues with brain functionality, and we try to compare them with healthy controls, and then we try to figure out which regions of the brain may have some issues, or they're having some problem that manifests in their everyday life, in their behavior, in their everyday work and performance and things like that. And then we share this information with the clinicians, and then they try to find better strategies to come up with better solutions to these diseases. Some of the diseases that we focus on is, for example, Parkinson's disease, autism spectrum disorder, schizophrenia. Right now, I'm particularly focusing on COVID-19 and so on.
Okay, so Rakib, you are in all the way before we dive into today's topic, so like our cognitive functions, right? So would you like to elaborate?
Sorry, you were cutting off. I'm sorry.
Okay, so I was asking that before we dive into today's topic, would you like to explain to us what you understand by the word cognitive functions?
Right. So, yeah, I will try to be as less technical as possible, but basically, anything that you do would have some sort of cognitive origin. So basically, for example, every day we use our memory, right? We figure every day when you wake up, you know that you are a father, you're a mother, and you have a child whose name is this and that. All of these are working memory that we work with. So that's a cognitive function. For example, every day we wake up and we use our hands, and we know where to put our hands to pick up what things. These are all cognitive functions. And then there is studies, understanding, and speech. For example, I'm talking to you in English, and even though we are bilingual, our brain is able to process that information and understand internally what I'm trying to say and what I'm trying to portray or depict in terms of what I'm in the topic and so on. And all these things are being registered in the brain. There is a language processing part of the brain, basically in the temporal lobe right here. And so we have a language processing unit, we have a memory unit, we have motor function, we have balance. For example, some people can't even stand up and cannot keep their balance. That's because they're having some issues with the cerebellum, which is right at the back of the brain. So these all fall into cognitive functions. And then there is the most important, the executive functions. For example, whether you decide to tell the truth or lie, that's an executive decision that you take. Should I do this, or what is right and what is wrong? All these things is in the frontal lobe right here, right behind this forehead. There is the frontal lobe of the brain, and we'll see some of these in the talk today. And so that's a cognitive function as well. Do you choose to do something right, or do you choose something to do wrong? All of this fall into some sort of a cognitive and executive function. And this kind of combines a lot of fields like psychiatry and neuroimaging and so on. And so it's very hard to hardline this topic into a single field. It's a combination of a lot of things. I hope that answered the question.
Yes, Alhamdulillah. Rakib, the first thing that I would like to ask you is, can you give us a feedback about where you are situated? Basically, you are in New Jersey. So, what
Yes.
actually made you want to start working with this particular topic in your PhD program? Like, what was the scenario at the peak time of COVID in USA?
Oh, yeah. So that's a very good question, and it's kind of relevant to what my predicament was at that time and even right now. So I live in Jersey City, which is in Hudson County in New Jersey, where during the peak time in US, in New Jersey, this was one of those places which had the highest number of death rates. So people were dying left and right in our area. In our own apartment, we saw people die. Uh, horrible scenes. EMTs coming in every few seconds. Different time of the night, we would hear the sirens blowing up because most likely someone has died from COVID and so on. So yeah, during that time, I was lucky because we have a lot of programming. I do a lot of programming and brain signal processing and image processing. I was able to. So I before COVID put us into lockdown, we were smart enough to make sure that we were able to log into our lab server, which we created. And so I was lucky that I was able to connect to the lab from my home. But at that time, so a team in IIT Delhi, India, they figured out that there might be something going especially wrong in India, although the second wave hadn't hit at that time. The cases in India were very segregated, but it wasn't as severe as we have seen now. So they started collecting some data, and they said that we're going to send you this data. Can you try to see if there is anything like important that you can find out from this? And we figured that okay, this is really relevant and this is quite like current, because we don't know what kind of neurological issues might manifest in the even the patients that are dying and also the people that are surviving. And that's when we figured out maybe we can start to like think about a project where you can identify this kind of, or we can address these questions, because no one has actually done that at that time. So this is a long process. fMRI is not an easy imaging technique. It takes a long time to do this. We have been doing this since I think September last year, 2020. And just now we have been able to process all the results, collect all the data, process, analyze them, and then alhamdulillah, we tried to publish them. They're both in submission right now. Hopefully they will get accepted.
Mm.
Yeah. So
So,
that's
you
the summary of the whole thing. Yeah.
So that's how you started working on this project. So I
Yes.
would like to ask you a question, as in, like, what made you think about the cognitive aspect of COVID-19? So, like, we were all thinking about seeing the end result, like people are dying, they're suffering from some disease. But what actually made you decide that are there any cognitive functions impact on a COVID recovered patient or a patient who's suffering from COVID?
Right. That's an excellent question. And I guess when I talk using my presentation, this will come up even better because I will give you some statistics. So, like, first of all, the medical community was all over the place. Like they didn't know what to do at that time, because they were trying to save lives of really severe patients. So they didn't have time to look at what's going on in survivors, because if anyone survived, they were just happy that they survived, right? And so, but a majority of these patients actually survived and they went back home, but we forgot about them, right? Because everybody was busy to save lives at that time of the more severe patients. And rightly so, that's what the focus should be and concentration should be at that time. But once things like, settled down and we were able to come out of that bad predicament and that huge fiasco. And so once we were able to stabilize, then slowly we started to realize that, there are several cognitive complaints coming out of survivors now. We thought that this was over because they have survived already. But turns out that's not the case, and they're having all kinds of cognitive deficits. Like some of them were having memory losses, some of them were having severe headaches, loss of consciousness even. Some of them couldn't get up. They would get up and they would fall asleep, just couldn't wake up in the morning. All of this, and the virus is not even in their system anymore, because they're PCR negative, because they have already crossed that 2-week margin and the virus has already gone through the process and they've survived the initial infection. So we thought there would be no worries, but then suddenly, we're hearing complaints from all over the place. That's when National Institute of Health, and I'm pretty sure everybody knows who Dr. Fauci is by now. He's quite a famous person in the US. So he's the head of NIH, and most of our work is funded by NIH, National Institute of Health. So NIH realized that this is something going to be that's very, very severe, and we need to focus on this. So they announced $1 billion, $1 billion. That's not a that's a lot of money. And once Joe Biden became the president, I think Dr. Fauci sat with him regarding this and he said, we need this funding because we need to investigate what's going on in these surviving patients. A majority of them who were hospitalized, but they were released because they were okay. But turns out they are not, because many of them, at least more than 40% of them, are having severe cognitive deficits. And we need to identify these problems. And that's when they announced that we're going to give $1 billion to the scientific community. Just try to figure out what is going wrong with them. And then we thought, okay, this would be a good opportunity to use that fund for good and to try to figure out what is going wrong. And it's very relevant and it's current. And hopefully our results would help the clinicians to come up with better solutions to this problem. So I hope that answers that question.
Yes, it does, Alhamdulillah. So, uh, most of us who have recovered from COVID over here, we never realize that what you are actually saying we're being taken seriously. Like,
Yeah,
there are very few people left who have not been affected by COVID at least once. So, and most of
right.
us, we have colleagues who keep on saying that we couldn't even sit for 30 minutes at a time because we used to go take a nap and again wake up and then work. It was like that difficult. And you said
Mm.
about the headache, then you said about the forgetfulness, and all these issues were very, very common and nobody took it seriously. They all thought,
Yeah.
it is like from weakness or things like that. So in the mind, like people are not taking that seriously and all, things like that.
Understandably so, because they figured that, okay, we are already safe. Why should we even worry? But that's what everybody thought in the beginning. I don't really blame them. But once you start to see these kind of symptoms, you really should be worried that I have just recovered from an infection. Most likely my infection has not completely gone away. And some residual effect is what's probably causing this. And so basically to answer to this kind of also creates a tangent to the first question that you had, why cognitive function? Because our worry was because our primary interest and the system that we focus on is the brain, right? The central nervous system. That's our focus. And what was interesting to us is to most of these cognitive complaints, headaches, loss of consciousness, memory loss, lack of motivation, severe lethargy, fatigue, which is the most common symptom in post-acute, now they call it PASC, post-acute sequelae of SARS-CoV-2 infection, and so on. So the most common of them is fatigue, like severe, lack of motivation to do work, very severe weakness, doesn't feel like, and almost feeling like falling asleep all the time. And so this was very, very common. In some cases, more than 70% of the patients kind of reported that they were having these issues, even though they survived the initial hospitalization. But the idea is that most of this, our question is, what organ of the body do all these symptoms converge to? And all of these are cognitive functions, and they eventually lead on to the brain. And that's when it's okay, we need to see this very seriously, because all of this lead to the brain, right? All of these symptoms would arise because of some sort of neurological deficit. And so again, so it's not us, the entire neuroimaging community were looking for it. So first they realized, okay, let's try to see if there is any neurological deficit. And in my presentation, I will show you some of this evidence from some acute patients where there were severe, like disturbing images, like of the brain having severe lesions all over the place, microbleeding, hemorrhages in several cognitive areas in the brain, or regions of the brain that are related to cognitive function and so on. Yeah. Hello, are
So
you with
Rakib,
me?
one of the things that whenever function, their oxygen level, yes, I am. Can you hear me now?
Yeah, so sometimes
Can you hear
you
me,
like,
Rakib?
yeah, I can hear you now.
Oh, it's
Sometimes it
probably
was
the
lagging.
network
So
issues.
yeah,
Okay.
yeah, yeah,
So what I was trying to ask you is
yeah,
that whenever somebody gets COVID,
yeah,
the first thing that they keep on doing is measuring their oxygen level. and things like
Mm,
that. And in cases where people are having breathing issues and others,
yeah,
probably the doctor will prescribe them a CT scan of the chest or the lungs and
right.
things like that to see.
Right, yes.
So what you people realized about the brain functionality of this? So was it very difficult? Like, what were the risks involved with scanning survivors, like with the MRI machine, where or the CT scans? Like, were they okay with it? How much did you have to convince them? How did you overcome this?
Right, that's an excellent question. Yes, it's never easy, first of all, but we have a very dedicated team, and shout out to them, to the team in India, the IIT Delhi. And so that's the Indian Institute of Technology in Delhi. So they were adamant about this, that we need to figure out what is going wrong in your community. So they were very advanced. Like even before the second wave hit, they realized this could get worse, and we need to figure out what is going wrong. So, and I'm telling you, it's not easy, because even if you survived at that point of time, no one was vaccinated. This is early September 2020. No one, we didn't even have a vaccine at that time, right? It's still under process, which means if you had an infection before, there is still a chance to have a secondary infection. So that means everybody had to be masked up. And if you mask up, it will automatically change your breathing, because a lot of the oxygen will, and a lot of the carbon dioxide will be retained. And having a high level of carbon dioxide will change how the cerebral, it's called cerebrovascular reactivity. So how the blood oxygen level changes. And if the blood oxygen level changes, that means there is a change in hemoglobin. And the hemoglobin is is originated again. So one of the elements of the periodic table is iron, as we all know, and that's a paramagnetic material, which is one of the sensors, we can say, like a biological sensor, which we use to identify like brain signals from fMRI, or magnetic resonance imaging. It says magnetic resonance imaging, right? So which means we rely on how these paramagnetic materials change in their properties in the brain. So if these things change, the signals will change. But that's a confounding factor, because we want to know what's coming. If there is a change in brain signal purely from an infection, we don't want to know if this change in reaction happened because he was just having restrictive breathing.
Hmm.
You see what I'm saying? So that
Yes,
can
yes.
create false positive results. And there was a recent study, I think, by a very famous person. I don't want to name them. So they found out that there was a change in a percentage signal change in the brain because of masking. But we had to put them on mask, because without masking, we would be risking the people who are scanning them. We have to put them in an MRI scanner, and it's not easy. Many people have phobia, because claustrophobia, so you cannot put them in a scanner. So these are all, so many different issues, right? And another thing is cost. For first of all, in US, if you want to do a single session of fMRI, it would cost you nearly $1,000 mostly, just for one session. So that's not easy, and if that data is corrupted, then $1,000 gone down the drain, and it's not that simple. So a lot of issues that we had to overcome. And again, big shout out to the Indian team who kind of did all of that and provided us the data. They did all the hard work, and they did all of that. They made sure that the environment was secured, it was sterile, that there was no. They made sure that the air was ventilated properly, so that there is no residual virus in the form of droplets in the room. So a lot of precautions had to be taken, which we don't really have to worry about if it was not COVID. So, but with scanning, all these things come in. And then there is compliance from the participants. They have to be compliant to be lying in a scanner for half an hour or so when we scan them. And it's a thundering noise, although we give them like earmuffs and so on to reduce that, but it's very scary. It's not easy. I don't want to scare people to not go into an MRI. Of course, do an MRI if you have to, but these things are part of MRI scanning, and that can be quite scary for some people. And these are all these are all conflicts that can happen during a scanning, and these are the confounding factors, I would say, and that makes it very difficult if the participant is not compliant. And if he's not compliant, we can't force him. That's just how it is.
Hmm.
If someone doesn't, even mid scan, if someone says no, I can't do this anymore, he has a full right to get out of the scanner, and we'll have to stop the scanning, and this happens. This happened also. So, and this is just how it is, right?
Okay.
A lot of
Yes,
complications
true.
can happen, but we have to overcome them. The point is that we overcame them. We were able to collect at least data from, I think, initially at least 20 patients. So that's at least a good sign. And then we also collected like completely healthy individuals who didn't have COVID ever. Like I think we had 23 healthy controls. So we had an overall like a sample size of I think 43. But then after data quality assurance, quality control, and so on, we have to remove some subjects because of data corruption and so on. Eventually, I think we had an effective sample size of 41 to 40 subjects. Yeah.
Okay. Okay, so my next question from this is that were you only working with COVID survivors while you were taking the MRIs, or were you also comparing it with the patients who were currently infected?
That's a very nice question. And in fact, this is what probably most of the reviewers of my paper would probably also ask me. And they do. And some of them actually did, to be honest. I don't want to disclose too much, but that is a very good question. And yeah, so I wish I could explain how difficult it is to do a scan, to scan a COVID patient. It's a lot of risk at that time, right? Now we can think of different ways after vaccination and so on. We can think of better ways to do this. But at that point of time, September 2020 was, or even before that, actually, they started at around maybe July or August, and then we got the data. We started getting the data from September, so it was peak time in US and also getting to the peak time in India. So it wasn't that easy. But that's a good question. Our design or study design should be, to be honest, that we should have healthy controls who have never had COVID, and then we would have some survivors, and then we would have some COVID individuals, and we can do like a group level analysis using some sort of analysis of variants, or even if we have covariates, we can do analysis of covariance or ANCOVA and things like that, if we have behavioral measures and so on. So yeah, we can design studies, or even it could be a longitudinal design, right? Where we have these patients before they had like, any kind of infection, but then they received, then they had the infection and we scanned them after some time after having the infection, then they recovered and then we scanned them again. That would give us a projection of how the disease progressed in their brain. And that would be a very proper way to do this. But it's just very, very difficult to invite someone back to do another scan. It's not that easy, but we are trying. We're trying to design studies like that. But if we could do that, that would be interesting. Yeah. So that's a fair question. That's a fair question and a fair point, and point to be noted. I just hope that we could do this, but it's really, really difficult, especially when someone has already COVID and being scanned. That's very, very difficult.
Okay, so we have actually a question from one of the viewers, and they're asking that how many other countries are also related in projects like this? Like, except India, you have mentioned India, and you have mentioned the US, they're working actively. So there are many first world countries who have the facilities available to them, but are they really working on this aspect?
Great question. If you look at the literature, so because I took it very seriously. So before you do a project, you have to do a literature review to find out who is doing what in the world, basically, not just in US, around the world. So I did take a look at papers from different countries. And I think some of the most early papers came from China, understandably so, because the epicenter of the disease was there. And I think the first paper that came out saying that, oh, we can see some neurological deficits or neurological manifestations in these patients, in acute patients, actually did come from China. But then soon I saw papers coming out of France, from Italy, from Iran, from I think I saw some paper from even I don't know, I forgot which other countries I looked at, because we don't usually look at the country. We more look at, like, we'd rather look at, England, of course, London. There were papers coming out of England too, several papers coming out of there, because England was also heavily affected. And then, of course, there is US. People are going left and right trying to figure things out. So yes, of course, the countries with facilities were trying, and other countries were mostly just busy, like, helping the patients. But it's not that simple to design a study at that point of time with that mindset that, oh, we need to figure out what is going wrong with them. But I also need to keep the patient alive. You can put them in a scanner. When someone is in ventilation, who's having mechanical support for breathing, you can put them into an MRI. You can't do that. So, but they did because some of the patients were terminal. They wanted to figure out maybe this has got something to do with their brain. So we should scan them to figure out if we can help them with something. So some of them actually did scan these patients, even in terminal situations. And that can be quite risky to the patient because the patient may die during the scan, right? That's a lot of risks. And unless an institutional review board, or as we know, it's called IRB approval, unless, because it has to be ethical too. And the patient has to give you the consent that, okay, you can scan my head. Or if he can't, someone from his family has to do that. So all this process can take time, can take materials, can cost a lot of money. So I'm not surprised that initially people were not mostly interested. But now, if you look at the literature, many papers are coming up because now once things have settled down, people realize that we need to go back and look at these patients who have survived at least. Because initially all the papers are talking about very, very acute patients, right? They were severe, they were all in severe condition. And as I said, most of them eventually died. Some of the results that I will show you, some of these patients actually never made it. So that's how scary it was.
Mm.
So it's not easy
So,
to design studies at
mm.
that point. Yeah.
Okay, so let's not freak out the patients who are going to go for an MRI. These were
Yeah, I
patients
don't
who
want
have
to.
died after the tests in the MRI tests, right? So,
Right,
okay,
right,
so
right.
you were just some time ago, you mentioned a word which was PASC or PASC. So, what is exactly that? That the post-acute SARS-CoV
Pass.
sequelae?
Post-acute sequelae of SARS-CoV-2 infection. That's what NIH called it. Yes.
Okay. So over there, like what were the most common things? Like what and were the symptoms permanent? Like the patients you have done an MRI on September, for example, have you done a follow-up MRI maybe sometime this year? And did you see if the symptoms are recovering or the symptoms are still existing in the same situation?
That's a great question. Actually, that's one of the questions from one of the people who were in my committee, like during my proposal defense, and they kind of suggested this that we should scan them a little, and we have submitted a grant. I don't want to say too much because they're all under process, but we have submitted a grant at NIH based on exactly answering that question. But we haven't been able to take a second time point
Okay.
of these patients. But I should say, based on the current literature, we saw that about 40% of more than 40% of the patients were developing PASC, and the symptoms persisted at various amount of time. In general, they can persist for more than 6 months, up to a year in some patients, and even more than a year in some patients. Right? This is based on current literature. In our study, we at least found 9 out of the 20 patients, which is again more than 40%. They have developed this kind of post-acute symptoms like fatigue, memory loss, loss of consciousness, and things like that. So yeah, that's a good question, and yeah, at least our estimate right now, or at least our observation from these patients so far, at least aligns with whatever is reported from the literature. And a lot of these questions will actually be answered once I show the slides. You will see this whatever I'm talking about. You'll see these statistics in the slide when I talk or when
Okay.
I present the slides.
Okay, so would you like to show your slides right now because we are getting screen
Hello?
sharing?
Yeah, sure. Sorry, you were cutting off. Yeah, I mean, you can. I think I have been given the privilege to share my screen.
Rakib.
Yeah. So I'm just going to share my screen. Okay. Can you see my screen?
Yes, we can.
I don't need that. I'm just going to minimize this. Okay. So this is a very simple presentation that I prepared very quickly just to not make it very technical. You can see my screen, right, ma'am?
Yes, we can.
Okay. So This is one thing that we're trying to do. We want to assess structural and also functional brain alterations in surviving COVID-19 patients. That's the title of today's talk, and that's also title. That's kind of the focus of our study, if you want to summarize what we're trying to do. And basically, we already know about most of these things. We know how that there is a novel strain of the coronavirus which is causing this, and we have these symptoms. But initially, what we saw is that it can attack multiple systems. So not only initially the focus was in the respiratory system, right? That we were having some issues with breathing, and people thought, okay, that's what it is. But no, soon papers were coming out. People are having cardiovascular issues. People are having pulmonary diseases. People are having neurological abnormalities. And of course, because we work with neurological or neuroimaging and neurological deficits, so our focus was in particularly neurological. Let me actually make it into a pointer so that you can probably see my screen pointer better. Just give me 1 second. Yeah. So can you see the red dot?
Yes, we can.
Okay, great. So this kind of shows the point that I'm trying to make. So there are several systems that are being affected. So not just neurological. So there are papers out there that show issues with the heart, issues with the kidneys even, and you will find various systems being affected, mostly because of the the bindings, like the binding ability of this particular virus with particular receptors and so on. And at that time, so this is some of the data that I collected about 2 months ago. This thing has obviously changed, but you can see if you go to the World Health Organization website in the data table, you can see that at that point of time, this is about 2 months ago, 135 million people were already affected and over 2.9 million deaths worldwide, which was quite concerning. And if I go to the next slide, and so if you go to the World Health Organization website, you will get mad because it's a lot of statistics from a lot of countries. One can get lost, like, okay, what am I supposed to figure it out? Like, what can I assess from here? So what I did was I took the top 3 countries just to see what is the trend in some of these categories. Right. So if you look at, this is around, I think, April 13 when I collected this data. So I collected some cumulative data and tried to present this in a graph. And you can see very clearly that, okay, initially the number of cumulative cases in the US, which is in the blue bar here, you can see that obviously they had about 30 million cases at that time. And India and Brazil soon rising at that point of time, but they were around maybe 12 million in both. But if you look at these statistics now, India currently has reached already 30 million, whereas US currently is around 33 million. So you can see that within a matter of 2 months, drastically things changed. And that's how fast this can affect, right? And I will tell more about the deaths. If you look at the cumulative total deaths, at that point of time, obviously it was I think it's still highest in US, but India and Brazil are soon catching up at that point. At that point, India didn't have much of deaths. You can see it was about 180,000 deaths. But now, if you look at the statistics in just about 2.5 months, it has reached 400,000 deaths already in the whole country, and that's reported. We don't even know how many of the unreported cases are there, and so is in Brazil. But interesting, if you look at the cases in the past 24 hours, look at India. At that point of time, they were having more than, at that time, more than 15,000 cases in just 24 hours. That's a very different picture from what you can see here. And this was an indication that there was a second wave coming there. But this was at the very advent of that second wave, when the Delta variant started to affect people and so on. And once you look at this, we understood that maybe there is something going on in India that we have to figure things out. And we thought that, okay, India would be a good place to start this analysis. And that was that's why we chose that site, particularly in India, where we wanted to investigate what is going on. So this gives us like a rationale of why we chose particularly there. And then obviously I talked about most of this, so I don't want to repeat too much and take too much time on this, that I told you that the first paper that came out from Wuhan, China, from 3 centers, including 214 patients, they showed that neurologic symptoms were found at least in 36.4% of the patients. And some of the cognitive complaints that they were having was dizziness, they were having headaches, they were having taste impairment, smell impairment, at least in 5% of the patients, and now it has actually increased. And there was impaired consciousness, which means they were coming out of on and off out of consciousness, which was quite dangerous. But this is again from acute patients who were already hospitalized in severe conditions. And they also show that if you're hospitalized, if your case is severe, most likely you will have a better chance, you'll have a higher chance. I shouldn't use the word better, but you'll have a higher chance of developing neurological symptoms, which is again very, very concerning, which means most likely if you were hospitalized, you would end up having some sort of neurological deficit. And so that was concerning. And then later on, more studies came out to show that, oh, there are other cases in different countries. Like I think this was from France and some other countries here that have also shown ischemic strokes, encephalitis, alteration of consciousness, confusion, even agitation. They were angry. So many abnormalities, and specifically some in the temporal lobe and so on. And then there was other imaging from the acute patients, which showed major damages in the major lobes of the brain, like the frontal, which is for executive function, then the parietal, which also works with memory and other stimuli related processing, and then occipital, which is for visual processing, temporal, and insular lobes, which affects a lot of which affects which processes emotion and affection and love, what we have for people and things like that. That's the part of the brain that affects them. So a lot of things were getting affected, and just to show the severity of that, this is some evidence from some acute patients. So you can see that this is a susceptibility weighted image. You can see these are the in the subarachnoid regions, you can see several hemorrhages as in so there was bleeding, internal bleeding in the brain in this patient. And then if you look at the vessel wall MRI, hello, are you there? Ma'am, are you there? Ma'am, if you can hear me. I guess I will stop sharing at this point, and hopefully if ma'am can rejoin, I can start from here. Um, I am going to try to contact ma'am. Hopefully she can come back. I think, hi everyone, welcome back. I think ma'am is having some technical difficulties. So unfortunately, I think we'll have to end the session right now. I hope I was able to convey some of the information. And although I wanted to talk a little bit more on the cognitive functions, but I guess we can conclude the session for now. Hopefully in the future, we can talk more. And I hope this session was helpful. And I hope that I was able to at least give you some insight on what the post-acute sequelae of SARS-CoV-2 infection may pertain to, like in terms of symptoms, and hopefully we can come out of this at the end of it all. With that, I would like to end today's session, and hopefully we'll see you again. Goodbye and good night for now. Thank you.